All right, so here we have a planet that has a mass 1/10 of Earth, 1/10 of the mass of the Earth. In the diameter, it's 1/2 the diameter of Earth, or the radius is also half of the Earth. We usually talk about the radius. The density of Mars relative to the Earth is most nearly. So the density is equal to the mass divided by the volume. So the density of the Earth looks like this. It looks like the mass of the Earth divided by the volume of the Earth. Okay. Now, if I'm going to do 1/10, so if you do the density of Mars, we're going to do 1/10 of the mass. Okay, mass over volume. How does the volume change? When I do half of the radius, you remember the volume is proportional to radius cubed. So that means if I halve the radius, it's going to be 1/8 the volume of the Earth. And that's because, remember, the volume is equal to 4/3 pi r cubed. So if I multiply the r times 1/2, then the volume would get multiplied by 1/8. Okay? And so this is going to be, 8/10, mass of the Earth over volume of the Earth. Or you can think of it as I'm multiplying by this by 8/10. So it's 4/5 mass of the Earth. So it's 4/5 the density of the Earth. So 4/5 as much. That's the number, because this is the density of the Earth. So that means the density of Mars, 4/5 the density of the Earth. The acceleration of a falling body near the surface of Mars relative to the Earth is most nearly. So the acceleration near the surface of the Earth is the g, the gravitational constant. And that's equal g mass of the planet divided by the radius of the planet squared, right? That's the formula we talked about. It's related to Newton's law of gravity, right? So again, the mass of this Mars is 1/10 the mass of the Earth, and the radius of Mars is 1/2 of that. So that's going to be 1/2 the radius of the Earth squared. And so what you're going to get is you're going to multiply by 1/10 on the numerator, and you're going to multiply by 1/4 on the denominator, right? Because it's squaring the 1/2 also. So that's going to make it 4/10 divided by, dividing by the fractions, multiplying by the reciprocal, g mass of the Earth over the radius of the Earth squared. So that's going to be the relationship. You multiply the mass by 1/10, the radius by 1/2, and you're left with, you're multiplying it by 4/10, or 2/5 as much. Right? So this is 2/5 of the gravity of the, this is for the Earth, this is 9.8 or 10 for the Earth, and so for Mars it's 2/5 as much.